everyone! My name is Anaya Singani and I am a developer advocate over here with MongoDB. So it's November and you know what that means. All of the super fun and unique fall favorite items are available at your local Trader Joe's. I know that Trader Joe's is my favorite place to go shopping for either Thanksgiving or any Friendsgiving or fall autumnal parties, and I'm sure that it's one of your favorites as well. And that's just solely because Trader Joe's honestly has it all. From everything but the bagel seasoning to their Philly cheesesteak bao buns, they have stuff that you don't even realize that you're missing from your pantry. But sometimes, the long lines at Trader Joe's and just the decision fatigue of deciding between all of the fall favorites or the seasonal options can get pretty overwhelming. But luckily in this tutorial, we are going to come up with a really fun way to ensure that you don't have to deal with all of that during your next holiday party. This is where the dream team, an incredible combination of Playwright and the LlamaIndex and MongoDB Atlas Vector Search integration come into play. So let's use these incredible platforms to create a Trader Joe's fall party planner. We are going to be using Playwright to scrape the Trader Joe's website for all of the fall related products, the LlamaIndex and Atlas Vector Search integration to build a retrieval augmented generation or RAG chatbot with all of our fall products as our data store. And then we're going to use LlamaIndex's chat engine to get the most interactive and conversational responses based on our fall product data so that we can plan the best autumnal party possible. So what is covered in this tutorial? We are going to be building a Trader Joe's AI party planner using Playwright, LlamaIndex, and MongoDB Atlas Vector Search. We are going to be scraping Trader Joe's fall items with Playwright and then formatting them for chatbot use. We are going to be setting up and embedding product data in MongoDB Atlas Vector Store for semantic search. And then we're going to be creating a retrieval augmented generation chatbot to answer party planning questions. And at the very end, we're actually going to be adding in an interactive chat feature or an interactive chat engine functionality for back and forth Q&A about fall party items. So let's go into all of these platforms in a little bit more detail for anyone that hasn't heard of them before. So Playwright actually makes it super easy to return dynamic website elements, which is the reason why we chose it for this tutorial. So after inspecting the Trader Joe's website, it was pretty clear that JavaScript is required to load the content and the various products we were able to see, meaning that the page content is rendered dynamically. So because of this, other pretty simple Python scrapers wouldn't work for the items that we're looking for, but luckily Playwright helps make things really easily digestible, and it can return all the elements that we're looking for pretty simply. And then LlamaIndex. What is LlamaIndex? So LlamaIndex is a framework that makes it really easy to use large language models or LLMs with your data. So you can create all kinds of AI-powered applications using LlamaIndex, and chatbots are one of them. So that'll be perfect for our fall party planner. Then, of course, MongoDB Atlas Vector Search. So that is a feature inside of MongoDB that allows for you to store and query your vector embeddings inside of your database. So it allows for you to build incredible applications that require semantic search or searching based on meaning and context rather than exact keywords. So in this tutorial with our party planner, we are going to be using MongoDB Atlas Vector Search as our data's storage and retrieval layer. It'll allow us to store all of our fall product embeddings and then search for the most relevant items depending on what we ask our chatbot. And last but not least, we can talk about LlamaIndex and MongoDB Atlas Vector Search integration. So what is this? This combines both platforms, LlamaIndex and MongoDB Atlas Vector Search. So it allows for LlamaIndex to actually go in and organize and query the data. And at the same time, MongoDB Atlas Vector Search has vector storage and semantic search capabilities. So all of our product information, which is going to be all of the Trader Joe's fall favorites that we scraped using Playwright, is going to be vectorized and then stored into our cluster. So that might be a little bit confusing for some people. So what exactly does that mean? This means if a question is asked, such as which 3 sides are best served if I'm making a turkey, LlamaIndex will get the most accurate product by comparing different vectors that are stored in MongoDB Atlas, so ensuring that all of the answers are based on overall meaning. And you'll be able to see all of this in action at the end of the tutorial when we fully build it out. So now let's dive into tutorial prereqs. So these are very important to have in order to be fully successful with this tutorial. First, of course, is an ID of your choice, and just to make things pretty easy, we are going to be using a Google Colab notebook, so I'll be linking that in the description box below, and please feel free to either try it out yourself or just run the code snippets. You will be needing an OpenAI API key as well, so please make sure that you have access. And this will cost a little bit of money, but it's super worth it. Especially if you're diving into AI for the first time or you're trying to build some really cool applications. And then, of course, please make sure that you have a MongoDB Atlas cluster provisioned. Make sure that you're using the free tier and that you have ensured your IP address is set to access from anywhere. And, of course, this is not recommended for production use, but for the sake of copying this tutorial, it'll be perfect. Also, please make sure that you have copied your cluster's connection string to a safe place because we will be using it during this tutorial. So once you have all of your requirements, we are ready to begin. Happy fall party planning!
So our first step is to scrape our Trader Joe's website for all of our fall items. So of course, our first step is just to inspect all of our fall favorites from Trader Joe's. And then we want to save them so that we can easily scrape the website. Trader Joe's actually makes this pretty easy for us since they already catalog everything under specific tags. So I've already gone ahead and I've clicked on the Fall Faves tag. And as you can see, these are all of the fall favorites. So we have our food, we have fall favorites that are beverages. And there we can just go ahead and see them under fall faves. Then we can see flowers and plants. And these ones also have a fall faves category, and then the everything else section as well. So once again, fall faves. So let's go back to food, and we can start here. Also, just keep in mind that since we are dealing with live data, these products and options may change depending on when you decide to scrape the information, so the products that show up for me may look different to you. And I recommend just going ahead and saving every single one of the URLs of what we want to scrape. So for example, as we can see here, this is the URL that I'm going to be saving for now, and it has the tag fall faves in it. And I can actually just go through, and you can either use pagination for this or you can do it manually. Makes it a little bit easier, but just go through every single page and go ahead and save that URL. So once we know the URLs that we're going to be scraping from, we actually need to go ahead and figure out which selectors we want. So we want to be able to format our products as name, and then we want to include the price. So the easiest way of going about this is to just go ahead and highlight the name of an item, and then we can go ahead and we can right click and then go ahead and click on inspect. Then this page is going to come up, and you can actually go ahead and just open everything up and make it a little bit bigger to figure out exactly where the name of each of our product is and the price. So as you can see here, after some clicking around, we were able to figure out exactly where the name of our product is and the price as well. Here we are able to see that every product name is located within an H2 class with this name, product card, card title, text, UIWLE. And then each price is located here inside of a span class, a span tag within a product price 350J class. So I recommend going ahead and checking 2 or more products just to ensure that this pattern is throughout. And if we go back up, we can see that every single one of the products is located inside of this li tag in the product list item 1elvq class. So this just means that we're going to have to wait for this specific class to show up when scraping before we can go ahead and actually extract the information within. So at this point, we know the URLs of what we are attempting to scrape, and we also know the selectors that we are going to need in order to extract all of our fall favorite products. And now that we have those things in our toolkit, we are able to go in and build out our scraping function. So let's go over to our Google Colab notebook. Our first step, of course, is to install Playwright.
So that can just be done very easily with pip install playwright install, and let's run that. And once that is done installing, let's go ahead and import all of our necessary packages. So import async.io, and then from Playwright async import async playwright. Let's run that. And then just keep in mind that we are using async because we are running everything inside of our Google Colab notebook. So now we can go ahead and we can start building our Trader Joe's scraper. And I actually have our scraping function off screen from my article that I'm going to be pasting in the description box below. So just to save some time, I'm going to just copy and paste that in, and then I will explain it. All right, so here's our scraping function, and we started off actually with manually putting in all the links we wanted to scrape. So once again, as I mentioned earlier, go through every single URL that you're trying to scrape, and then I just put them in nicely here, and I made sure that each link had a different category. So we have 6 food, 1 beverage, 1 flower and plants, and then everything else. And I recommend, of course, to use pagination for this part, and I'm just putting in the links manually just for the sake of simplicity. Then, of course, we just looped through each URL, and we made sure to wait for the selector to load. And once again, the selector, as I mentioned a couple minutes ago, is the product list item 1EIVQ, and that's where all of our products are listed under, or where they live. And then we went ahead and we got the name and the price, and we made sure to specify exactly where those elements live as well. So under the H2 tag and the span tag. And then we just want to make sure we go ahead and make the price a number in case, otherwise when we run this, it'll save the price as a string, but we don't want that. Just in case we want to be able to use like an aggregation pipeline or anything else, you should always make it a number. Now we can go ahead and we can run this and then see what we get. So we've run that, and as we can see, we have all of our fall favorite items. So we have our mini brioche bites, if you remember from here. Let me go show. Go fall faves. Mini brioche bites, pomegranate, the chutney, and just so many more. And as we can see, they all have the name, they have the price, and then they have the category. So we have a ton of food, and then we have some beverages such as cinnamon spiced coffee and apple cider. So to keep track of our items, let's just go ahead and quickly count them. So we scrape products, count products, and then we can just print out our, and let's see how many. 108. Okay, very cool. Now let's go ahead and let's save all of our products into a text file so that we can later use it on in the tutorial when we're using our LlamaIndex and Atlas Vector Search integration. So we can name it whatever you want, but I think I'm just gonna name it, I like to name it with, because I've done this a couple of times, I like to save it with the date that I scrape. So this is November 12th. Text. Okay, and for item in scraped products. And this is how we want to save it, right? So we want the name, and then we want, we want that to be closed. We want the price, and this we want it to have a $sign in front of it because we were dealing with American currency, and then the price. And then we also want the category. So that can be done just like this, same way as we did the other two, category. And then we can do a new line for everything. Okay, let's go ahead and let's run this. Cool. And we should see it, nice. So we should see it right over here. Perfect. I like to go ahead because if your runtime disconnects on Colab, you will lose your files. So I like to just go ahead and download it just in case I need to very quickly and easily still work with the same data. So now that we have all of our Trader Joe's fall products, let's go ahead and build out our AI party planner. So this can be our part 2. So in order to be successful with this tutorial, this is the quick start, and I will be, of course, linking it in the description box below, but this is the quick start that I used to build this part of the tutorial. And we're going to be going over how to use the Atlas Vector Search with LlamaIndex to build a RAG application with chat capabilities. So this section will cover in detail on how to set up the environment, how to store our custom data that we previously scraped on Atlas, how to create an Atlas Vector Search index on top of our data, and then to finish up, we will actually implement RAG, and then we will use Atlas Vector Search to answer questions from our unique data store. So I recommend before going into this part to look through this quick start because we're going to be using this with a couple of changes. So a lot of the code that I'm going to be using in this tutorial is going to be taken from here. Perfect. So first things first, let's go ahead and install all of our necessary libraries. So I'm just going to copy and paste that from the tutorial and then let that run. Now we can go ahead and we can import all of our necessary import statements. So this, once again, is taken from the tutorial I just showed. We can go ahead and we can run that as well. And while this is running, make sure that you have your OpenAI API key and your MongoDB Atlas cluster connection string because we are going to be using it right now. I will be taking this off screen to put in my sensitive information, but then I will meet you back once it's loaded. Perfect, so all of that is in. And now we can go ahead and assign our specific models for LlamaIndex, just so that it knows how to properly embed our file. And this is just to keep everything consistent. So we can go ahead and we can run that. Now we can go ahead and we can read in our text file with our scraped products. So we are doing this using the simple directory reader from LlamaIndex. And then text files also aren't the only files that can be nicely loaded into LlamaIndex. There are a ton of other supported methods. So I really do recommend checking out some of their other supported file types. If we have interest in that, I will link that in the description box below. And then I need to change the path because that is taken from my previous time when I ran this. Perfect. So let's run that. So here we are just reading the contents of our file, and then we are actually returning it as a list of documents, which is the format that LlamaIndex requires. So now that our file has been very nicely read in, let's connect to our MongoDB Atlas cluster and then set up a vector store. So you can feel free to name the database and collection anything that you like. we are initializing a vector store using Mongo Atlas Vector Search from LlamaIndex, which will allow us to work with our embedded documents directly in our cluster. And I have just named my database as Trader Joe's Products, and then the collection is Fall Faves. And I've just kept my vector index name as Vector Index, which is the default name. So let's go ahead and run that. Cool. And then since our vector store has been defined by our vector store context, let's go ahead and create a vector index in MongoDB for our documents inside of our sample data. And just run that. Perfect. So once this cell has run, you can go ahead and view your data with the embeddings inside of your Atlas cluster. So let's go ahead and look at that. Very cool. And it has everything that we want. It has everything in 3 documents, but that's fine. This should still work nicely. Cool. So in order to allow for vector search queries on our created vector store, what we need to do is we need to create an Atlas Vector Search index on top of our Trader Joe's Products Fall Faves collection. So we can do this either through the Atlas UI, or we can go ahead and we can just do it directly from our notebook. So let's go ahead and let's run this. Perfect. And then once this index is up and running, we can actually go ahead and check under the Atlas Search tab, and it's pending. So once that is up and running, then we can go ahead and start querying our data and doing some basic RAG. So I'll come back once this is up and running. Oh, it's ready. Okay, cool. So now that we have our Atlas Vector Search Index up and running, we are ready to actually bring our AI Party Planner to life. So we are going to continue with the Stream team, where we will use Atlas Vector Search to get our documents and LlamaIndex's query engine to actually answer our questions based on our documents. So to do this, we will need to have Atlas Vector Search become a vector index retriever, and we will need to initialize a retriever query engine to actually handle queries by passing each question through our vector retrieval system. So this combination will allow us to ask any questions that we want in natural language, and it will help us match with the most accurate documents. So we can go ahead and we can first, of course, instantiate Atlas. So vector store retriever will be equal to vector index retriever. Index is equal to vector store index, and then similarity can be top K 5. So now we want to go ahead and we want to pass the retriever into the query engine. So query, oops, spell that wrong. Retriever query engine retriever is equal to vector store retriever. Cool. And now once again we want to, or not once again, but we want to prompt the LLM. So this is where we are asking a question, right? So we have a query engine, and then our actual query, we can just go ahead and we can ask which plant items are available right now. Please provide prices. So let's run that and see what we get. So once that runs, we can see that it shows us exactly which plant items are available right now with their prices. We can see the mum florets, assorted mum plants, and then the grande succulent skulls. Awesome. But what if we want to keep asking questions and then we want to get responses with memory? So let's go ahead. Let's quickly build a chat engine. So I'll just add this in as another part. So part 4 chat engine. So instead of having to ask one question at a time, like up here, about our Trader Joe's products for our party, why don't we go ahead and incorporate a back and forth conversation to really get the most out of our AI party planner? So we first need to initialize the chat engine from our vector store index, and then we need to enable a streaming response. So the way to do this is by using something called condense question mode. It's used to ensure that the engine shortens their questions and then rephrases them to make the most sense when used in a back and forth conversation. And then streaming, of course, is going to be enabled so that we can see the response. So I'm just going to have with the input ask away and then type exit to quit. So in order to quit, you have to type lowercase exit. And then if exit happens, the conversation is going to break. So let's go ahead and let's see what happens. Hi, I am planning a fall party. Let's see what it says to that. Cool, very nice. I want to make a turkey. Which 3 sides with prices and reasonings would be best? Oh, awesome. Okay, cranberry ginger chutney, mashed sweet potatoes, and savory squash pastry bites. Cool, so I can go ahead and use this. Let me say to which drinks should I serve? I want something caffeinated. Cinnamon spiced coffee and maple espresso black tea blend. Awesome. As you can see, this is our little AI party planner for Trader Joe's, and hopefully this is super fun to use while you're planning your upcoming Thanksgiving or other fall parties. Yay, we've built an incredible AI party planner on our Trader Joe's fall products. Congratulations, you reached the end of this tutorial. And in this tutorial, we have built a super helpful AI party planner using Playwright to scrape all of our favorite fall products from the Trader Joe's website. And then we have used the LlamaIndex and MongoDB Atlas vector search integration to save, embed, and query our data using natural language. And then we also took it a step further and incorporated a chat engine into our tutorial just to take things a step further than just a standalone Q&A. So I hope that you enjoyed this tutorial. Please like and subscribe and leave a comment if you did enjoy it. And please check out our Gen AI showcase. I'll have that linked in the description box below. And if you would like to connect, you can chat with us in our developer forum. Thank you so much, and I'll see you next time. Bye.